Anybody hear me? Looks like it. All right. Hi, my name is Ray, and I'm an Android developer. I work at Square, where I work on our main app register. And I'm here today to talk to you about just how we build that thing and the patterns and libraries we've developed to keep it something pleasant to work on instead of something that makes us want to gouge our eyes out each day. So there's kind of four facets to the Square style. We achieve the modularity in our app by using views. Views are our Lego bricks. We keep that a sane thing to do by using Dagger for dependency injection to keep most of the brains of our views elsewhere. We use a library that we've been developing for the last few months called Flow to handle navigation, backstack types of duties. And then we keep a handle on scoping and memory use with the library called Mortar. What I'm not going to be talking to you about is a framework. Each of these things is an independent library. You can use them, you can not use them, and most of what I'm talking about really comes down to a pattern of development, which can be made easier by just use of libraries. But there's no Square activity that one has to subclass to write an app in the Square style or anything like that. So let's get started. We'll talk first about modularity. We're developers. We want things to be modular. We want to be able to snap little bits together and make sure that I can test part A without having to build up part B and that kind of a thing. And on Android, we've gotten really clear guidance about how to deal with that over the years. We started off with an activity as kind of our unit of work, which, got the job done, but it's big. It takes care of the whole screen. It has a nasty habit of completely being destroyed whenever the user rotates their device, that kind of a thing. Honeycomb time came, and we were offered fragments, which looked really promising. They're a lot finer grained. We could work with portions of the screen at a time. We could kind of set up neat transitions and so on. And it's where we jumped into fragments with both feet. We took a lot of code that was sort of kind of isolated and moved it into individual fragments, and we got a lot of benefit from that. But we also got a lot of pain in terms of general flakiness of the app. Fragments doing exciting things like reviving themselves on rotation, kind of headless, just because they had once been displayed and they were in that kind of a mood. The fact that everything was asynchronous and you never quite knew what was being displayed where, when, and so on. And just the whole folklore required with fragments. Got to have a default constructor, and it's got to be public, and 5 other things that I don't think about anymore because I haven't used them in 6 months. So we figured there had to be a better way. And we realized that better way had been there all along, which is the view class. Views, don't get confused about whether they're solving controller problems or view problems. They're just kind of focused on receiving touch events and handling 2D graphics for you. They don't really have a life cycle, but it's not that hard to kind of let them know that there's one around. And so really the talk should just end here. Build your apps out of views, use Dagger to make it a little bit simpler, and you'll be happy. But we'll go on, there's time to kill. So to frame the talk, let's imagine that we are building an app. We want to build it in this style, just using views. And let's make it a music player app because music players have lots of individual bits of music. It's a good thing to try to talk about examples with. PM thinks it would be good if this was a social music app, so we can add some of that. And they found this nice cloud graphic, so we should make it a cloud-connected music app. And I think that gives us enough kind of scenarios to work through here. So we are starting this from scratch. We jump in, and we're going to make this an app that gets all of its componentization out of views. And so the first thing we'll do is build an activity, and we'll set its content view. We'll use a layout to do that. The layout's probably going to look something like this. It's going to go instantiate our custom container view called player view. It's going to have an image to show the pretty picture of whatever song is running, a button to press to make it go. And the custom implementation of the class will probably look something like this. I'm going to construct the view, and now I'm not a complete idiot. I'm not going to actually put all of my model logic and business logic inside this view. I'd like that to come from someplace else if I can get away with it. And the obvious someplace else to do that is the custom application. So I've declared my player app in my manifest, and that'll be where my model logics actually hang out. The particular obvious benefit about this is that when my view gets destroyed for various configuration changes, the app is just going to keep on chugging along, and I'm not going to have a lot of problems to worry about with that. So by instantiated my view. I've grabbed my context to find my application. I'm pulling my model objects out of that. I've got a nice click handler here, which is probably going to do something like see if the jukebox is playing, and if it's not, start it. If it is, stop it, and make sure I can tweet so that everybody knows just what it is I'm listening to. We're not a really viable product yet, but this is our first iteration. We've got something to work with. And then finally that application that is vending all this stuff, that looks pretty simple too. A couple of getter methods, we're good to go. So we've got a structure now where we've got our application, and it's got references out into our model world, and we understand what's going on. But it can't really be this simple. If I'm going to have a jukebox object and a Twitter object, they're probably going to have dependencies, like the jukebox is going to need to be able to play audio, and the Twitter object is going to get to some kind of an RPC service to actually make tweets. And those guys aren't going to be as simple as that. You know, they're probably both going to need to have access to some kind of an HTTP library. Twitter API is going to need to hold on your credentials. Maybe I'll store those in Android shared preferences. So, okay, I'll add a few more fields to my application, and I'll do a little bit more instantiation in the onCreate method of my application. I've got constructor arguments that pass things around. I still know what's going on, but this is going to get out of hand pretty quickly. It's a nice pattern to just have all of my dependencies off on the side and check them all from one place, but if I can use a library, I'll spend a lot less time typing and a lot more time actually enjoying my coding. So this is where the Dagger dependency injection system comes in, and this is the point where I need to know how many people are familiar with Dagger. Oh, good. The talk falls apart if people don't know it, and then we have to spend some time, but we'll still gloss through it just to get the basics in hand. I'm not going to go into details. It's an entire talk all by itself. The URL there, and then the last slide shows Jake Wharton's most recent talk on Dagger, which is a truly excellent one, and it's used in Android. But just to get the basics covered, Dagger gives us a few basic annotations for us to declare the dependencies that individual parts of the app want, what they'd like projected into themselves, and lets them define where those dependencies actually come from, build their modules and provide methods. It's originally inspired by Juice. It's a dialect, it's a re-implementation of Juice written specifically for Android. It's code generation based rather than reflection based, which solves a lot of performance problems. It also does less because we need less, and so there's less to understand. It's worked quite well for us over the last 2 or 3 years. So to get dependencies in a Dagger code base, you use an annotation called inject that indicates I want one of these when I exist. Somebody go get them for me. There's 2 flavors of that injection. You can decorate individual fields to be injected, or you can declare a constructor as your kind of designated initializer, to use an iOS term. Field injection looks something like this. This is basically your way to provide services to objects that you didn't get to create yourself. The stuff that Android built for you, field injection gives you a way to actually get stuff in there without typing it over and over again. And it's generally something that will do to itself. So we started off with our player view looking like this, where it was reaching out into the context and grabbing in everything that it needed. When we give it the Dagger treatment, it's going to look more like this, where it's annotated in particular fields as injectable. It'll still go ahead and grab that application, and it'll ask the application to inject me, please. The other flavor of injection is a constructor injection. This is for the objects that you create yourself, or when you start using Dagger, what Dagger creates for you. Typically, your model plots is really anything that Android would have created for you, anything that you would have said knew this or knew that. If you find yourself saying knew too often in the Dagger app, you probably screwed up. So, for example, our jukebox model object would probably look something like this. We have an inject annotation there telling Dagger that this is the way to actually build one of these. The arguments to the constructor tell it exactly what other objects need to be created to make this thing go in. And we get another little magical decoration there, singleton annotation, to make sure that Dagger knows that we only ever want one of these things. No matter how many people ask for this, no matter how many views get created as the configuration changes, it should be the same jukebox that they're all talking to. So that's how you decide what you want. You also have to be able to provide these things. For something that was built with a constructor, you're good to go. Dagger already knows how to make it, and you're done. But there will be lots of times when there's some configuration or some code that needs to happen with that. And in this case, you put together modules that Dagger will assemble together for you. Module is a polite word for factory. We're Java developers. We're supposed to be embarrassed by the term factory, but that's pretty much what it is. We indicate a module class by annotating it appropriately. We identify its factory methods with an app provides annotation. And then we take all of this mess, our injected classes and our modules, we smush them together, and Dagger creates an object graph for us. This is the actual factory of factory. This is where all this stuff comes from. So in our application, we know that we've got the Twitter guy and the audio guy. They both need the HTTP guy. We might define a module to build that stuff. That looks something like this. So if it was just a factory, it would have methods to build the various things that needed to be built. If we add a couple of annotations to it, now it's a Dagger module, and we're good to go. And we can still use that singleton annotation here as well, just like we did on the constructor build class. The way our application is going to look when we've got something like this going is we're back to that same old onCreate method, but instead of having 5 screens of create one of these, I need one of these, I need one of these, we just tell Dagger, I would like an object graph, here are the modules that define it, and here is how my clients can inject themselves. So that's Dagger in a nutshell. There's much more to it. I encourage you to dig in. So we have a plausible way to build an app out of views, using Dagger to inject things into those views so that they have a chance of being testable, so if they're going to survive configuration change. But we've only got one screen. It's not a very viable product if I have to do everything with the one button. So let's imagine that we're going to make this into more of an actual browsing, data providing type of app, where we've got our list of albums on the left here, and we can imagine that we tap into one of these and we'll get the track list, and we'll tap into one of the tracks and we'll get to start playing the thing, something like that. What we've been using at Square, since we gave up fragments and we give it the fragment manager and we don't have transactions, is a tiny little library that Logan Johnson put together called Flow. And Flow kind of started big and has progressively gotten smaller and smaller and smaller to the point where it does very little indeed, and it works pretty well. Basically with Flow, you are, you're building a stack of Pojo screens. It's just enough data to represent a particular location, a particular state in your app. It's the moral equivalent of an intent or a URL. It's like a bookmark if you're writing a web app. So for our app, the intent, the screen objects will probably look something like this. If I have an instance of album list screen that I've put into the flow backstack, that means I need to show the album list. There's no other particular state. I don't have lots of album lists yet. I haven't gotten around to playlists. A screen to represent a particular album might have the ID of that album, so I can fish it out of some database somewhere. A screen to represent a particular track in a particular album will have a couple of fields in it. Ideally, these are mutable objects. They're definitely not model objects. These are keys. These are selectors. These are enough for your app to wake up in a particular spot after hibernation and say, "Oh, I'm the album screen. I should be showing album ID number 23422." That kind of idea. I'll do a couple more eye charts here of how this actually would look in your code. So if this is our custom view for displaying the list of albums, we're going to have, after we inflate the thing, we're probably going to be setting up click listeners on our list view. And what we're telling the app is that when somebody taps on a particular album, and we want to find our flow instance, a singleton shared across the app, go to a new album screen. Here's the ID of the album I want you to see. That's it, you're done. The app is going to go there now. The screen object itself, like we said, it's just a simple Pojo. It's got a final field. It's immutable, so why bother with getters and setters and bump your method count? It needs to do typical Android equals and hash semantics. It's a value object. Nothing really magical. So other aspects of Flow, we've got these screens. We need them to actually survive through hibernation and such, and we do that by storing Flow's backstack into the activity bundle. So you're going to have to write a few lines of code to do that, and you're going to have to write a few lines to implement a small interface to actually show the view that represents a screen when you're told to do so. So the way that's going to wind up looking in a typical app is in my main activity in the onCreate method, I'll be defining a backstack. If no bundle came into this onCreate method, then I must be in the cold start. So I'm going to create a new backstack with a single entry, which is the album list, which is where I like to start things. Otherwise, I'm going to divide it from the what's that thing called, the bundle. One interesting argument here is the parser, which is not misspelled. Again, this backstack needs to live in your bundle, which means at the end of the day it has to be parcelable. But having to make all of your screens parcelable sucks. Parcelable is a really powerful but really chatty and boilerplate UI or API. So Flow provides you with a hook where you can do your own serialization on the side. For example, the sample app with Flow has a simple parser that uses JSON to actually serialize things and then cram that into a parcel and get that into the dictionary. It lets you avoid a lot of boilerplate. Full disclosure, we don't actually use that one in production. Some of us have measured some things and convinced ourselves that it makes that janky. I'm not convinced, but we actually go through the pain of writing out all of our parcel implementations by hand. I think pretty soon we're going to try out auto parser, one of the other auto things related to parsing. Hopefully we'll stop doing that. And if it works well enough, we'll probably throw away the parser API entirely. Anyway, so we have our backstack, we've created it or we've restored it, and now we need to actually go somewhere when it tells us to. This is the sole method on the Flow listener interface. Our activity is implementing it. This is what Flow calls when anybody anywhere in the app says, time to go here. And the three arguments there are the backstack, the direction, whether we're going forward or backward, or this is just a restore, maybe we're just replacing things, and then a callback to fire off when any of our animation is done. That callback is actually a very recent addition, like Thursday. And it turned out that Flow didn't pretend to be re-entry. If I was navigating to screen A and as a side effect that said, oh, I actually need to be in screen B, Flow would kind of pretend it was working and kind of odd things would happen. You tended to see that if you're really wailing on the back button and things would start to overlap and so on. That's fixed now, and it required adding this callback. So if you're not doing any animations, or if you're just a simple show me what's going on type of situation, you just call it immediately. If you are using animations, you'll put this in a non-animation end handler and call it then. We'll go into that more in a bit. So here we are showing stuff. The last piece of the puzzle is how do I handle the back button? How do I handle the action bar up button? And the answer is, well, one or two lines of code. Back to our activity. Our back press method is just going to look something like this. If the flow can't go backward, then it's probably at the top, and so you should just let the default behavior happen, which will shut down your activity. If you're using an action bar from the system, you will bind an option item handler onto its up button, and it'll look something like this. And it's the same kind of idea. If flow can go up, then we will go up. Honestly, we find that we're using the go up stuff a lot less than we actually expected to. It's almost never the case that you have a distinction between what the up button does and what the go back button does. It happens in apps like, say, the Play Store, where I'm looking at this app and I can click through to warp to related apps or other things that other people install. In a case like that, I want the back button maybe to take me back to the app that I came from. I want the up button to be structural, and that's where the go up stuff comes in. There is a strong chance that we will find a kind of less clunky API to express that, but this is how the thing works for now. So anyway, we tell the flow the backstack to go up. The way we actually communicate that we have an up to go to is a screen can implement an optional has turn the screen that should happen when I go up. If that's not implemented, then go back and up are the same, and that's the deal there. So, very little code for a lot of behavior. I'm making a lot of promises, and can I actually keep them? No, not really. Flow is a minimal API, like I said. It gives you exactly what you need to get the job done, and then there's no extra handholding built into it. And we, like probably anybody else who is using it, have written a lot of code to go on top of that to handle our transitions, to deal with composition of nested flows and that kind of thing. It's been through several rounds on the Register app. That's been copied back over to the Order app, which is Logan's territory again. And he's honed it down into something really pretty pleasant and pretty small at this point. So a couple of days ago, I took his app flow and his screen switcher reusable classes from Order. I've put them almost exactly into the flow sample app. Pretty sure that's in the flow master branch at this point. There's a PR that's refining it still. This is still settling down, and I'll be tweeting when it is a little more stable, but it should be within a week or two. These things kind of help keep the promise that you probably thought you were getting, which is, could you just show the screen for me, and could I just have the flow on the screen, please, and you don't have to think so hard about where you're getting them from and where you're putting them in. We'll go through a few more code slides to show how we'll actually use this stuff. So now our main activity, remember before we had our create method where we were looking at the backstack and everything else. We're instead instantiating a handy class called the flow bundler, which will take care of that serializing and deserializing for us, and which will initialize with an abstract class that provides our default screen on our cold start. So you'll notice that this, you should notice, but I broke the slide. 1 second. So right there, where there should be an argument, there isn't. The backstack should be being passed in here, which gives us the option for our cold start screen to be something really simple and quick. That's like showing your logo, and when it's done, the app is loaded, it's able to say, okay, Flo, now here's where I really wanted you to go. And in this mechanism, and in that Go method we saw before, you probably noticed that it's always the entire backstack that we're passing in. Flow never tells you, show the screen. Flow tells you the backstack is in a new state. The reason it does that is your backstack could represent something like, say, a nested screen, a modal dialog, something like that. So you may need to actually restore 2 or 3 frames of the stack in order to have everything painted to show the are you sure dialog is actually at the top of the stack. So that's never hidden from it. Back to the shell. What are we looking at here? Right, so we're still in the activity, and now we're in our onCreate method. The AppFlow package provides an interface that views that know how to show screens can implement, and we provide default implementations of that built around a screen switcher helper class. It comes out of the box with a thing called the frame screen switcher view. Your activity doesn't have to know that. All the activity cares about is that layout that it loaded from the same root layout XML file is going to have somebody named container in it that implements this. Yes, I can show screens. He'll fire up the flow bundler to get his life going, and it'll tell the AppFlow service, okay, start. Just make things go for me. Down here in our Go method in the activity, we're just delegating any chores about how to display a screen to this view. It's the view's job. And if it's the view that came out of the box with Flow, it'll just put it full screen, and it'll do some left and right transitions for you. Let's see. Back press, similarly, we don't tell Flow about it directly anymore. When the back button is pressed, when the up button is pressed, we tell our view. The view has the chance to decide, do I want to deal with this, or am I showing a view that also might have something to say about this? Does it implement the on-back press method as well? This can drill all the way down. And so if I'm so the back button gets pressed up at the top level, and each view that's displayed at the moment has a chance to say yes or no, I want to handle this, and then maybe the 23rd level of view is a text editor that needs to pop up a dialog saying, no, wait, you spelled your name wrong. It has a way to abort that, and you didn't have to build any kind of event passing mechanism yourself. So, we've got our flow. It's actually worth installing now because it doesn't make you do all of the work. We have a mobile UI that's plausible. What happens if I want to have different layouts for different form factors? Maybe I've got a tablet version of my the music player, and when I rotated landscape, I'm going to show my navigation slider rather than leaving it hidden on the side there. How do I do that in this world without rewriting all of my code? And the answer, happily, is it works out as easily as we thought it would. The techniques that I'm showing you here are kind of what we're doing in register, and very definitely what we're doing in order. And sooner or later, we'll backport the order techniques into register, and I'll be telling the truth about everything. So we're back in our main activity. Remember, the very first code that we showed was, I'm a main activity, I have a create method, and I'm going to load a root layout. That doesn't change. Just like we realized that views are an excellent tool that have been with Android forever, the layout mechanism is a really wonderful thing. It provides us with a lot of power. Android knows which of 25 layouts have the same name to load for us, and so it does all of the thinking about, was it a tablet, was it a phone, was it this, was it that? Why did I put this slide here? Right. So the point here is where we first had just a single root layout sitting up in the default location, we've now added a new layout of that name that's expected to have a screen width that's a minimum of 600 dps, and that's in landscape orientation. That SW 600 dp, that's kind of our metric for am I a tablet or not. It's been serving us pretty well so far. Maybe we'll need to get finer grain when people start buying 13-inch tablets. We'll see. And then this is what is going on in our new alternative version of the root layout. It's going to instantiate an entirely different view. The tablet landscape root. This is from my music player, not the generic thing. This is specifically the custom layout that I like to show when I've got the phone in that configuration. It's going to have on the left side about 20% the navigation list like we saw. On the right side, it's going to have one of those generic flow frame switcher jobby guides. Over here in the actual implementation of this custom root, it has a show screen method, and all it's doing is before it lets the flow provided screen switcher render the screen, it's going to tell the nav list, hey, I want you to update this screen. You can see here is that the screen is able to declare, I belong in the playlist section, I'm a Google song, I'm something like that. It's simple, but it's effective. It gets the job done. In the sample app that's shipping the flow, we have a more complicated example that is a more honest-to-goodness master detail type of view with things like the screen can tell you that if it's a master list or if somebody's drilled through this and they're actually going through a detail now, and we'll show masters on the left and details on the right. If you've got tricky animation happening on both sides, we've passed in that callback, and we can do countdown latch types of things to make sure that all animations are done before we give control back to flow. That's a lot of detail to go into in a talk here, but it scales nicely. One more example, though, of what you can do with this technique. This is actually copied and pasted out of the Order app in development today. We said earlier that we find fragments to be a source of pain and terror, or implied it strongly. Don't have real good feelings about dialogues either, for very similar reasons. And Order has decided that any modal business that they need to take care of is just going to be a nested view with a frame layout and some dimming and event intercepting, and this is how they implemented it. In the show screen method of the main view in Order, the screen comes in, it's time to show it. We check to see, hey, is this screen an instance of modal screen? Okay, I better start intercepting touches. I'm going to take my modal container, which is some other view in this layout that maybe knows how to show itself when it's been given something to show. I want you to show yourself, make sure you call me when you're done, and we'll return. Otherwise, if it's another kind of a screen that has other kinds of side effects, we'll show that thing, and we'll hide the modal. It's the basic idea, but I understand what this code does. All of the code that I've shown you so far is as synchronous as it can be. I fire into the flow tells me what to do. In the case where I need to create some asynchronousness, I'm able to tell it when control is gone. I'm never in a race situation that I didn't create myself. My tests tend to pass, things like that. So, and there's the nice magic move effect to emphasize the code I just talked about. But there was a cheat in here, way back. So we've created these views, and we've created this flow, and all of the views are injecting the flow to say, I want to go here, I want to go there, and stuff like that. But how are they actually getting their hands on it? Because if you remember way back in the beginning, if anybody is still awake in this warm room, we set up an object graph in our application context. And in our activity, we created a flow object, but we never actually shared access to that flow object with anybody. So how is it that our views and our activity and everybody else are actually getting onto them? This ties into one more feature of Dagger that I didn't talk about before, which is its ability to spawn child graphs, basically scopes. So what we're showing you here in a kind of abstract way is, let's see, so our root graph is that object graph that was created in the application when we first started out. And that's where our jukebox and our tweeter and all those things come from. What we want to be able to do is create a child graph of that, a subscope that provides services owned by the activity, in this case our flow instance. And then all of that, this activity graph winds up being contained in the main activity. And that means that anybody who can get their hands on the activity can be injected and see both of those things. You create something like that in an object graph with this plus operation. Creates a child graph for you with all this extension. The code looks something like this. I'm not going to spend a lot of time on it, but because we're trying to prevent you from writing most of it, you basically, in your module annotation, you'll tell Dagger, hey, I define a new scope. Here's the one that I extend. That's not required, but it does turn what would be runtime errors into compile time errors. Go Dagger. And then the module itself provides access to that flow that our flow bundler created for us. One thing to note is that this module is not a static class. It's a dumb class. It's a Pojo. It can't have superclasses, but it can be an inner class. So it is able to actually provide access to anything that the activity itself defined for anybody else downstream to inject. So we'll probably set that up in the onCreate method of the activity. It'll get its hands on the application, find the root object graph in there. We'll call the plus method with its new high-end the activity module, and then provide an inject method kind of like the activity provided before. And our album list view can grab the activity and inject itself from that. That's how it's able to get it to flow. So that's handy. That's one less lie being told, and the mechanism still works. We talked before about one of the reasons that we do this kind of thing is to survive configuration changes. Android's delightful habit of blowing the world up every time your user sneezes. Do you each remember the first time you realized that was what was going on this platform? It took everything away. So one of the big problems with that kind of a situation is asynchronous activity. Remember that we're a cloud-based app. So if somebody hits my play button, then I'm going to probably make a request out to the cloud somewhere to start playing my music, and then we're going to rotate our phone, and then the response is going to come back, and the view that initiated the response isn't there anymore, and I lose. What we tend to do instead is we use a model view presenter model, or pattern development in Register at least, and even the apps that don't use a formal MVP type of structure are all still doing this kind of I have singletons hanging off of me that do the actual work for me pattern. When you're working in a world like this, your view has delegated almost all of its brains to the presenter. If this is the music player view, then this is the music player presenter. They're kind of a one-to-one pairing. The presenter is a monopolist on the services of that view. Nobody else will ever talk to it directly. The view will inject the presenter to find out which one it should be using. The play button gets hit. The presenter makes the call. The first view goes away. A new view wakes up and says, "Whoa, can I have my presenter, please? Presenter, any news you hear about, tell me about it." The response comes, and the view updates nicely. It's not rocket science, but it took us a while to figure out it. In the code, it looks something like this. Any view is going to inject its presenter. When the view is finished inflating or when it attaches, both work depending on exactly what we're trying to accomplish. If you say presenter, I'm the only view that you know about now. When the view goes away, it's attached from the window, it tells the presenter, forget anything you ever knew about me. The presenter itself is going to look a lot like the view itself used to look like. Now the presenter is injecting all of the dependencies. Now the presenter has the, hey, somebody click my button method, and it's going to make the asynchronous calls and receive the responses and that kind of a deal. So that's the vast bulk of the Square style. This is how literally every one of our apps gets built at this point. Whether or not they're using Flow, they're all using Dagger, they're all putting their brains in boxes that they inject into views, and we lack a lot of our fragments. But I haven't talked yet about what we use Mortar for. Mortar solves a problem of taking that scoping. Right now we have two scopes, right? We have our application scope, we have our activity scope, but what happens to all of those singletons that we instantiate as we're navigating around the app? They just sit around there consuming memory and consuming memory and really not serving any purpose beyond that. To get a handle on that kind of thing, Mortar lets you take that scoping notion and scale it infinitely. Any screen, any subscope, any portion of your app can have a short-lived scope using the same Dagger child graph stuff, but without requiring a lot of bookkeeping on your part, and so the extra resources can get reclaimed. I give the entire talk so that I can burn the pigs. That's the only reason for doing any of this. So what Mortar gives you is, well, pretty much you've already seen what Mortar gives you. It encourages you to work in that style by giving you a couple of tools to reduce the boilerplate there as well. So it really takes care of Object Graph Plus chores for you because it is another minimal library that leaves a lot of the work up to you. It nests things, blah, 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 I said this. So the way it actually winds up looking, we'll go back to our screen objects here. Remember our track screen, it has some IDs, it has a parent because it has an up button. Well, now we're actually going to make it define a Mortar scope as well. And we do that using some integration stuff that hasn't quite been open sourced yet, but will be this week and is in the Stack Overflow post right now verbatim. To integrate the display of a screen with an annotation that declares, when you show this screen, this is the Dagger module that I want you to instantiate. And that is going to provide access to the view in this scope with the actual screen instance here. So now my screen view or its presenter can not only inject the flow and inject the jukebox, it can inject what's all the information I'm actually supposed to be showing here right now. And a nice trick is that, again, this module can be an inner class, not just a static inner class, so you've got ways to sneak information around your app. So let's go back to another eye chart that we saw earlier. Way back, we have our track view, which had its play button, and we moved that play button method into the presenter that's going to work on it instead. And I apologize to people who can't see over the heads to get to the punchline at the bottom of the screen. Our play clicked method is kind of gross. If we look at it word by word, we're finding the backstack, we're finding the current screen on the backstack, we're casting it to be a track screen because that's what it should be, and then that's how we're deciding, hey, what is it that I should be showing? Life is a lot cleaner if we can just inject that screen as another constructor argument and just write a simple line like jukebox play, the album ID in the screen, go. And once we've got that level of encapsulation in our presenter, unit testing becomes a really, really simple thing to do. I did mention testing a lot. Here's a test. Are people familiar with Makito? Is that news to anybody? Nods. Okay, take it as read then. We have a simple Makito test of this track view presenter, mocks the jukebox, mocks the tweeter, makes a real screen because it's a Pojo. Why would you mock a Pojo? We do our little setup method to create our mocks, and then we can write tests that read like, when the jukebox is playing, then return true. Okay, the jukebox is playing right now. Presenter, the play button is clicked. Let's verify that you told the jukebox to stop. Our code is littered with stuff like this. We try to keep them pure unit tests where we can. Fortunately, Jandroid fights you on that, providing stub exceptions when you try to use parcels and bundles and that kind of a thing. So we will tend to use the roboelectric test runner on our tests to mock things that Makito can't mock, or not to mock them as much as just make them instantiable. We have seen bad effects of this. There are things that look like pure unit tests that should be pure unit tests that somehow get racy. We'd love to find other alternatives, and if people know of any, please post. But that really is Mortar. Most of what I told you along the way with Flow, the patterns there, the presenter class, that kind of thing, Mortar gives you a reusable presenter class. Mortar does the scoping for you, and it gives you enough access to the activity lifecycle that you can distribute the burden of persisting things as well. So in a Mortar presenter, we're actually extending the built-in view presenter class, much reduced lifecycle from what you're used to on Android. When the presenter is actually in a scope, it will get told, hey, wake up. The first time it is attached to a particular view, take view is called with a new value, it knows that its view is available, and it'll be given access to the last bundle that was written. Anytime the activity is told to save this state, all of the active presenters get a chance to write stuff out too. That bundle is namespace safe. You don't have to worry about stomping on other global values put in by other participants. And then when you get torn down, you've hit the back button, you've left that screen, you get an exit scope method if you need to tear stuff down. That's the entire life cycle. We used to say that it was only these two methods. It's grown a little bit, but we still haven't seen a reason to do anything beyond this. And these are what Mortar offers you. I've got a couple more charts about how to set up Mortar. We'll skip those because we're running out of time. The main trick that Mortar uses to actually have its way with your app is it wraps context for you, or it gives you tools to, when I'm displaying a view, wrap the context that will be shown to that view, and they can find the Mortar plumbing by injecting it as a system service. You don't know that. Your code just says, Mortar, find me the scope for this particular place, let me do stuff with it. Or if you're using Presenter, you probably don't need to get that actively involved with it. So there we go. That's what we do at Square. We're about out of time, but maybe we can try to sneak in a couple of questions. And we are hiring, as every Square presenter should have made abundantly clear. And we have this really rad new New York office in Soho. I can't say enough about it. The floors aren't very level. The chairs roll kind of the wrong way sometimes, but they're working on that. And there's free lunch. So I think we can take a few questions if we're here quickly after that. Yes, sir.
So I use Mortar, and so you've got sort of two concepts in Mortar. You've got the idea that you can create these sort of scopes, and you can control the life cycle of those scopes. And so aside this idea of presenters, actively model for your views. So what's the synergy between those two things that can help to sort of in the same library put them together and one that can really work without the other?
I'm going to try to repeat the question, but I'm not sure that I can. So is it that,
what is the specific synergy between view presenters and being able to control the life cycle?
Okay, so what is, why did we tie both view presenters and scope duties into one library? It's a good question, really. Didn't really occur to us to do it in any other way, honestly. One point is you don't actually necessarily have to do it that way. You can set up lots and lots of arbitrary scopes. That's not a requirement. If you set up Mortar and you just declare the root scope to it and you never annotate any other scopes, then there will be one scope. You still have the view presenter stuff going on. The view presenter is still injectable and can still find its way to whatever else is happening. I guess maybe the answer is that if they don't work together really well, they're neither of them very useful, and you want to try to find that balance of making them convenient to use together without hopefully enforcing it in there. But I can't hand wave more specifically than that. So yes. Scratching his head. Any other questions? Yeah.
Do you do integration tests with the views?
Do we do integration tests with the views and the presenters? We do now. This is what Demetrius was talking about yesterday. A big part of the reason that we made the move from fragments to views in the first place was to make our app more reliable, both in terms of reducing our crash rate, which went down by a number. I don't know it, but it did. and also reduced a lot of the flakiness and integration testing types of scenarios, so that Dimitris actually could create burst and could set up our testing environment and have a high degree of confidence that things will happen when he tells them to happen 99.9% of the time instead of 80%. Which is also part of the reason that Dimitris has heroically done the bulk of the work to convert the register from fragments and scattered activities into one activity with a bunch of views. It's easy if you have Dimitris do it. I think we do one more. Yeah.
Any habits of using flow with Dagger 2?
Have we looked into using flow with Dagger 2? No, but we really want to. Very curious about it. Flow, and in particular Mortar. I think I'm hoping that a lot of the duties that Mortar is doing for you will kind of happen with less effort with Dagger 2, but I don't have the source yet. I don't know. I think that we're in the way of the next talk, so thank you very much.